Abiotic natural attenuation, ANA, is a recently recognized important naturally occurring process that relies on reactive aquifer minerals to degrade recalcitrant contaminants like chlorinated solvents. However, ANA reactions in the field often occur at rates that are too slow to reliably measure in the laboratory. Therefore, it is difficult to quantify how long it would take ANA for contaminated groundwater to reach cleanup objectives. This SERDP project aims to address this challenge by developing a novel method which measures the oxidation reduction potentials, ORP, of the reactive aquifer minerals as a predictive indicator to estimate the abiotic degradation rates of chlorinated solvents. Our previously funded SERDP projects have demonstrated that the ORP of reactive minerals correlates well with contaminant reduction rate constants for different types of organic compounds with both laboratory model mineral phases and DoD contaminated aquifer materials. This project is to further advance this approach towards practical applications to assess abiotic natural attenuation of chlorinated athenes. Our approach measures the ORP of a reactive mineral slurry using a commercial ORP electrode, which is a simple measurement practitioners are familiar with. There are two keys to obtain a reliable and accurate measurement. First, we need to add a mixture of soluble chemical compounds called electron mediators during the measurement, which will significantly improve electrical responses to the reactive solid phases. Typically, we see a rapid decrease in ORP values after the addition of mediators, indicating the mediation effects. Second, we need to conduct the measurement in the absence of air to avoid oxygen interference to the ORP measurements. We developed a 3D printed cap that will allow continuous headspace purging with nitrogen. The cap can fit in on a 4-ounce soil sampling jar to perform ORP measurements under these conditions. Then we applied mediated ORP measurement to a wide range of reactive aquifer materials collected from different DoD sites archived by previous SERDP ESTCP projects. We created a redox library for DoD sites where abiotic natural attenuation could be relevant. Additionally, we have shown that the mediated ORP values formed a statistically significant negative correlation with TCE reduction rate constants. Based on this correlation, the ORP values can be used to predict the range of abiotic natural attenuation rates of chlorinated solvents at contaminated sites. In summary, this SERDP project developed a novel and simple method to measure the ORP of reactive aquifer solids that are responsible for ANA. The measurements can be performed in less than 10 minutes, either in laboratory for those well-preserved samples or on sites in the field for freshly collected samples. The ORP measurement provides a simple way to characterize the reactivity of the reactive minerals, which allows quantitative assessment of ANA rate for transition of contaminant plumes to passive management.